Question 5. A girl G riding a bicycle constant velocity 3.5 meters per second at time t is equal to 0. She passes a boy B sitting on a bicycle that is stationary as illustrated in figure 2.1. As you can see, at t is equal to 0, the boy sets up to catch up with the girl. He accelerates uniformly from time is equal to 0 until he reaches a speed of 5.6 meters per second. Okay. In a time of 5 seconds. He then continues at a constant speed, and at time t is equal to big T, the boy catches up with the girl, and t is measured in seconds. So the girl passes by stationary boy with uniform velocity. This it is the girl is not accelerating at t is equal to 0. Now boy for 5 seconds, um, it accelerates until he reaches 5.6 meters per second. After that, he continues to travel with the constant velocity, and t is equal to big T. He reaches the girl. Okay. State in terms of t distance moved by the girl before the boy catches up with her. Okay. You see, the girl is moving with 3.5 meters per second, uniform velocity, and the boy catches her up at time is equal to big T, right? So distance traveled by the girl at in this time, it's simple 3.5 velocity into time. Velocity is 3.5, not velocity. Speed is 3.5 into constant velocity. Yeah, constant velocity 3.5 into time is equal to big T. Okay, so 3.5 T, it's very easy. Since she is not accelerating, so in this time she'll be traveling velocity into time distance, right? So 3.5 T. So I'll write as girl is 3.5 T. Now they're asking for the boy determine distance moved during the acceleration. So the boy from velocity 0 till velocity 5.6, final velocity is going to be 5.6. For 5 seconds, he accelerated. Okay, so I can use SB. Displacement by the boy is equal to UT plus half AT square formula. So for first 5 seconds, he has uh, traveled this distance. Okay. Now we don't know acceleration, right? How do we find the acceleration? V is equal to U plus AT. Okay, time we know 5 seconds. U we know initial velocity is 0 for the boy. So I can find out A is equal to final velocity 5.6 divided by V by T. Final velocity after accelerating is 5.6 divided by time is 5 seconds. So we are going to get 5.6 divided by 5, we are going to get 1.12 meters per second square. Now, I can put it here. This is anyway going to be 0. Half into 1.12 into time is 5 square. Okay. To 5 into 5 to 14 meters. So SB I can write 14 meters. This is in meters too. So the boy, while accelerating, he traveled 14 meters. Okay. The distance moved during the time that he is moving at a constant speed. Give your answer in terms of t. So, you see, he caught up with the girl at time is equal to t. But for first 5 seconds, he was accelerating. After 5 seconds, he was moving with a constant velocity. So he moved with a constant velocity for t minus 5 seconds. The first 5 seconds, he was moving with acceleration. So for t minus 5 seconds, he has moved for constant velocity. Now, at this time, his velocity, you see, he has reached 5.6 meters in time 5 seconds. And then he continues with constant speed 5.6 meters per second till time is equal to t. So, distance will be the velocity into time. Time we know this is t minus 5, for which he was not accelerating. Velocity, constant velocity will be 5.6 meters per second. Okay. Use your answer in A and B to determine the time taken for the boy to catch up with the girl. Okay. Now, let us consider this is SB1 when he was accelerating. Let us consider this as SB2 when he had constant velocity. Is this. Now, distance of the girl or position of the girl will exactly be equal to the position of SB1 plus SB2, right? Why am I equating things? Because if the girl has traveled this distance, the boy has to, in order to catch her up, boy has to travel same distance. So initially he was accelerating SB1, and after that he reached a constant velocity and traveled for SB2 distance with constant velocity, finally reaching this position and equaling the distance between him and girl. Okay, so I can write SG is equal to SB plus SB1 plus SB2. Okay, now SG is distance traveled by the girl, displacement by the girl, I will say, or the position, which is 3.5 t. We have already found out, and SB1 plus SB2. SB1 is 14 plus SB2 is 5.6 t minus 5. Okay. Why am I doing this? I'll repeat it again. Girl has traveled this distance or girl has displaced by this uh, length, the constant velocity. In order to catch her up, the boy must travel the same displacement. Initially, he accelerated. Finally, he was moving with a constant velocity. So, while accelerating, has traveled this distance, so this displacement. While traveling with a constant velocity, he displaced by this, which has to be equal to SG. I mean, addition of this which has to be equal to SG in order to catch her up. That's why I could write this and finally replacing this terms. Now, bring t terms one side. T. This is 5. So I can write 14 point plus 5 t minus 5 into 5.6, going to get 28 here. Now 3.5 t minus 5.6 t is equal to 14 minus 28 minus 14, sorry, minus 28 plus 14 is nothing but minus 14. Now this side it will be 3.5 minus 5.6. It's minus 2.1. T is equal to minus 14. T is equal to minus 2.1. Minus 14 here. Minus minus gets cancelled. So 14 divided by 2.1, we are going to get 6.66. 6.667 seconds. So this is how we find out the time. Time will be 6.667 seconds. That's it.